Stella uses optical sensors to measure different wavelengths of light, and you need to consider the field of view when you're designing these optical instruments. What
Yeah,
might go wrong if the field of view is too wide or too narrow on a Stella sensor?
I'll rephrase that a little bit. How
Okay.
does the field of view affect what you're doing? If you have a really narrow field of view, what that means is if you're up at some height above the thing that you're looking at, which you always are, you're not going to look at it right smacked against your face. You're going to be able to see stuff in a narrow area. And if you have a large field of view, that area is going to be really large. And for non-imaging sensors like the ones we have in Stella, where there's just a single photodiode collecting light, it's going to average everything it sees in that circle. So if you are way up in the air, looking down at a field and a parking lot, it's going to average the color or the light intensity or the temperature of that field and that parking lot so that you will get less information. Like looking down at a pizza with a single pixel sensor, if you take in the whole pizza and you average it out, is it going to be yellow or red or green from the peppers? It's going to be all of those mixed together. Whereas if you get closer or you have a narrower field of view and you can zoom in on a particular piece of pepper, the pizza will look more green in that area. How the sensors that are calibrated that we start with. Okay.
Okay.
Um, so most of the sensors that we use have built-in microcontrollers in them, and they're calibrated at the factory, and then the calibration is programmed into their little microcontroller. So when you ask the sensor for a value, it reads the value and then looks up the calibration and then gives you the corrected value. So that lets us get much more accurate than we could get 10, 20, 30 years ago, just because they have built-in calibrations. If we want a better calibration, we're going to have to do that ourselves. And so we'll need a light source that we understand how bright it is. We'll need ways of cutting down that light source without changing the color of that light. Those are neutral density filters or gray across the whole spectrum. One of the things that we can do to make our measurements more accurate that anyone can do is to look at a reflective reference and then look at the thing you're trying to measure and then look at that reflective reference again. So we want a reflective reference that will give us as much light back as possible. So we use white polystyrene foam. And we like polystyrene foam because it's kind of white from whatever direction you look at it. In fact, not kind of white. It's white from whatever direction you look at it. And we're making a measurement of just how well spectrally it works at different angles. Like if you have a velour type fabric, you might get more of a blue from one direction and more of a red from another direction. That would be not a good reference surface. So what you want to do is look at the styrofoam, look at the thing you're trying to measure, and then subtract those measurements because the styrofoam tells you how bright it is outside. If you're in the shade or a cloud goes over the sun, or it's just later in the day, you're going to have less light available. So you don't want to make a measurement that is just a measurement of the total light available from that plant that you're looking at. You want to look at the total light available from the styrofoam and then look at the total light available from the plant and subtract them so that you know what's coming back from the plant. In any science and pretty much any engineering, differential measurements are going to be really important. So the way that they figured out that there was infrared was they put a thermometer in the part of the spectrum that was below the red just to see what would happen. And the thermometer heated up. But they took the thermometer out of the infrared and it cooled down and they put it back in the infrared, which they didn't know was there. They were just guessing. They put it back in. They looked to see if it warmed up. So suppose that you are doing the dishes. And so you've got your hands immersed in warm water. So your hand temperature is really different from what it normally is. And let's say your kid sister or kid brother comes up to you and says, I'm not feeling so well. Can you check my temperature? And you put your hand on their forehead. your hand is all hot from the water, so you won't be able to tell what their forehead temperature is like because your hand temperature is all confused. So what you do is you say, all right, go get your other twin brother or sister, not twin, just any old brother or sister, and bring them over. And you say, all right, so this person is maybe feeling ill, and this person is feeling fine. So if I check with whatever temperature my hand is, if I check the forehead on this one and then I check the forehead on that one, and I see that there's a difference, I can say, all right, this person who has a warmer forehead is maybe not feeling so well. Maybe they do have a fever. Whereas if the temperatures are the same, you can say, I don't think you have a fever. You might not be feeling good for some other reason, but you might not have a fever.